Hello, everybody. Welcome back to the Python tutorial seminar series. Today, Kevin Paul will be covering Jupyter Notebooks, and I'll hand it over to him in a second. But before we begin, I'm going to review the code of conduct. So by joining this Zoom call and participating in this tutorial seminar series, you're agreeing to adopt these values and engage in respectful communication only. If we see any inappropriate remarks or something like that in the chat, you'll be removed by one of the co-hosts. The seminar, like the previous ones, is only an hour long, so we can't stop to give individualized help, but the co-hosts and your fellow participants will be in the chat to hopefully provide assistance. And if that doesn't work, there'll be the recording and one-on-one help afterwards to help get everyone back up to speed before we continue. And some learning resources that we'd like to direct you to are the Python and Jupyter documentation, as well as Stack Overflow. And with that, I will hand it over to Kevin.
Thank you, Julia. I will kind of present a few slides to give you a little bit of an introduction here first. So thank you. Welcome to our Introduction to Jupyter tutorial here. This is intended for people who are very new to Jupyter, who've never seen it. There are advanced features that we're not going to cover, but we may be able to cover them at a later time. Before getting into Jupyter, though, I wanted to cover a little bit about Conda. We've had some questions over the past few weeks that indicate that there may be some confusion around Conda. And some of you have heard of Conda. We've talked about it in the past, although not very much, which is probably why there's confusion. Talking about Conda as a means of installing software. You've also probably heard us talk about having virtual environments created by Conda and installing software into those virtual environments. And if you were in the last seminar that Julia gave a couple weeks ago, you also heard us talk about pip, which is another way of installing software. So let me try and address some confusion around Conda before we begin into Jupyter. First, Conda versus pip. Both of these are package managers, which is to say both of them are used for installing and uninstalling software. That means we can use Conda, for example, to install the NumPy package, which is a third-party Python package for dealing with numerical arrays. But you could also use pip to install NumPy. And you can just as easily uninstall with either Conda or pip, although we recommended using pip to uninstall if you installed with pip and Conda to uninstall if you installed with Conda. Conda is also a general purpose package manager, and pip is a Python-only package manager. What that means is that you can use Conda to install Python itself, but you can't use pip to install Python because pip actually needs Python to operate. Also, as we discussed in the last tutorial, and for those of you who are familiar, if you download a software package that has a working setup.py file installed, you can use pip to install that downloaded package directly from your hard drive using a command like this, where dot is a reference to the local current directory where setup.py is assumed to be. There is no equivalent with Conda. You've also heard us talk about Conda as a means of creating and managing virtual environments. And pip is really just a package manager. That means that there's a command for creating these virtual environments, which is very similar to the instructions we gave everybody for this tutorial. This command here is a way of creating a new environment, in this case, my_env, and installing package 1, package 2, and so forth into that environment. It's sort of like running these three commands in sequence. You create Conda to create an environment, then you'd activate that environment, and you'd use Conda install to install packages into the active environment. But before you can really understand what this is, we need to talk about what are virtual environments. And the easiest way to understand that is to think about your system, whether it's a remote system like Cheyenne or your local laptop, as a collection of software packages. Each software package has its own version and so forth. There may be some packages that are just standalone packages providing certain functionality. And then there may be other packages, as I've displayed down below, that are Python specific packages. You can create a virtual environment to install completely different set of packages that do not interfere with the system level packages. And that's kind of nice because you can install Conda and create virtual environments without having system administrator privileges, where you may need system admin privileges to install things on your system. In this particular example, in the MyEnv environment, I've actually created an environment that has a different version of Python than is on the base system, and in fact, a different set of packages in that Python environment. You could also create an environment that doesn't have Python in it at all and install that with different software packages and maybe different versions. When you don't have any of these virtual environments activated, these are the software packages that you have available to use. Now, I've bundled the Python package with Python itself in this example, because that's how Python packages are installed. They're connected to the Python that is installed with them. They're bundled with Python itself. So when I run, for example, Conda activate my env, I get that environments packages. They come to the forefront, and now these packages are what I have available to use. You can see Python in this environment has now superseded the one that was on the base system. And therefore, all of the packages that were bundled with Python are now what I see. And I don't see the packages that were bundled with the system package. But as you can see up above in the non-Python packages, packages that were in the new environment supersede what was in the base system. When I do Conda deactivate, I go back to my previous system as if nothing had changed. When I run activate the other environment, now you'll notice here, this environment doesn't have Python. So when I activate it, these are the packages that I have available. I still have the base Python available and all of its installed packages because I did not install Python into my new environment. Okay, so hopefully that gives you a little bit of an understanding of what Conda environments and virtual environments are, and we'll use that at the end of this tutorial. And now what I'd like to do is really get into Jupyter. I think the hardest thing to answer is the answer to this question: what is Jupyter? There are a lot of things in the Jupyter ecosystem. If you've heard of Jupyter, you've heard of all kinds of different Jupyter things, and you may not know how to keep them all straight. And so that's what I'm going to try and give you an overview of today, is what is Jupyter and how do you use it? So to understand Jupyter, you need to understand 4 base components. The first component are Jupyter Notebooks. The first component is the Jupyter Notebook. Jupyter Notebooks are files. So you think of them as a file with the extension .ipynb. In the case of Python, for example, this could contain Python code, but it doesn't have to just be Python. It could be Julia or Python or R even. In fact, that's where Jupyter gets its name. It can contain equations, plots, pictures, narrative text that's very neatly arranged and rendered. So in a sense, it's sort of like a runnable paper. a paper that has code you can actually run in it. The second component in the Jupyter ecosystem you should be aware of are Jupyter kernels. These are the software engines that sort of sit behind or underneath the notebooks that run the code that is embedded in the notebook itself. The third component is JupyterLab. This is sort of the preferred application. It's not the only one, but it's the preferred application we're going to discuss today for how to create and write Jupyter Notebooks. And lastly is Jupyter Hub. This is the fourth component you may have actually heard of. Jupyter Hub is a means of authenticating users on a remote system and creating for them a JupyterLab running on that remote system. So in other words, Jupyter Hub is used for remote execution only. It's what gives you access and easily launches for you JupyterLab on the remote system. Whereas JupyterLab itself is what you would use to run locally. And that's what we're going to do today, is run everything on our laptop. So that local execution model is going to look like this. We're going to start out and launch JupyterLab, and we're going to do that from a terminal application. So if you followed along in the previous tutorials, you'll be familiar with launching a terminal and launching commands from that terminal application. When you launch JupyterLab from the terminal, it will immediately take you over to a web browser. Think of this as being like Google Docs. You actually have an application running in your browser. That's what JupyterLab does, is it runs the user interface, the application in the browser. Then when you get around to opening a notebook or creating a new notebook, JupyterLab launches a kernel running in the background that is capable of executing the code in that notebook. That kernel can be tied to any number of different languages. As I've already mentioned, Julia, Python, and R were the original three, but there are kernels that allow you to run many different languages nowadays. In the remote execution model, which I'll remind you is not what we're going to be doing today, you start off in your web browser. You point your web browser to a URL that points to a Jupyter Hub. And on that Jupyter Hub, you authenticate on the remote system. After authenticating and possibly providing additional options, the Jupyter Hub will launch for you JupyterLab running on that remote system, and then redirect JupyterLab back to your browser. So what you see is what appears to be the exact same experience you'd have as if you would run JupyterLab locally. And then, as usual, when you open a notebook through that interface, it creates the Jupyter kernel for you. So for the rest of this, I'm going to basically give a demo, and you're welcome to follow along. If you can follow along, if you have problems, please ask them in the chat. Or if you can't keep up, we will post the video on this and you can refer back to it later. So I'm going to stop sharing my presentation here, and I'm going to go over to my terminal window and share it. Okay, so hopefully now everybody sees my terminal. Before this, you should hopefully have run this command that's already printed here. That's how we recommend you install JupyterLab. And that means I've got a Conda environment called Jupyter Tutorial, and JupyterLab is installed in that environment. So to activate that environment, I'm going to say Conda activate Jupyter Tutorial. And now I should have Jupyter available. I'm going to create a little workspace for myself just to do all of this in by creating a new directory. I'm going to call it Jupyter Workspace. And I'm going to go into that directory, and it's from this directory that I'm actually going to launch JupyterLab. And you launch it by just typing the command Jupyter space lab. If this is the first time you're running it, it can take a little time to get started. But once it gets started, you'll start seeing output, and it should immediately take you over to your browser. But I want you to stay looking at your terminal here for a little bit and notice the output that's in your terminal. This is all log information for the running JupyterLab. And you'll notice I haven't got my prompt back at the bottom of this terminal screen because the JupyterLab is still running. Okay, so you'll notice it gives you instructions even here to hit Control-C to stop the server if you want. I can try that and it'll ask me if I want to. I'm gonna say no, I'm gonna keep it running. And then what I'm gonna do is I'm gonna go over to my browser, which is where everybody should be looking now. Okay, so now I'm going to share with everybody my browser, and this is hopefully what you are seeing on your browser as well. Okay, so hopefully everybody is now seeing this. If not, there's something wrong with the install, or maybe we need some help fixing your Conda environment. But this is what you should get with a just base installation of JupyterLab. Let's do an overview of what you're seeing here. So very first, what you should see is up at the top of your browser window, you should see a menu that has your typical file menu, edit, all the way over to help. Below that, the bulk of this space is something that's called the main workspace area or the main work area. And it currently has a little launcher tab in it with some shortcut buttons for creating different things in our Jupyter workspace. On the left is a collapsible sidebar. It should start you off in the file browser over here, which is indicated with a little file folder icon. Below that is the running tabs and kernels. Below that should be a table of contents, and below that will be an extensions manager. We're not going to use extensions in this demonstration here, so we're going to ignore that. We're not going to look at the table of contents either, but we will use this file browser and the running kernels and terminals tab. This left sidebar is collapsible. So if you have, for example, in this case, the file browser activated, you can deactivate it by clicking the icon again, and you can collapse that sidebar and give yourself more real estate in your workspace. The other thing to note is this bottom gray bar below everything. That's an information bar that is context sensitive, and we'll look at what that provides through this tutorial as well. Okay, let's take a look at the file browser tab in the left first. If you haven't activated it, go ahead and activate it. You'll notice at the top left, you'll see this blue button, which gives you the ability to create a new launcher tab. And I can create many of them, and you can create them at any time you want, and you can shut them down like so. Next to that is the ability to create a new folder in your workspace. Everything down here is what's in the contents of the directory that I launched JupyterLab from. So that's my root directory. I can create a new directory here. I'll say call it test. And you'll see it appears down here in the contents of my root directory. If you right click on anything in the contents, it gives you another menu, and you can do something like delete it, which I'm going to do. There's a upload files into this root directory, which can give you locally the ability to move files from one place into your root directory if you'd like. But if this is running on a remote machine, it gives you the ability to upload files to that remote machine. And while this file browser usually stays in sync with what's that's in your root directory, sometimes it doesn't and it needs to be refreshed. And so there's our little refresh button up there. Okay, the running kernels tab, you'll see doesn't really have anything in it. We'll get to this in a little bit. So let's go click on the running kernels and terminals tab here, and let's go over to the launcher. We're going to start our tutorial with the terminal. So click on this button down at the bottom here, and it should launch for you a terminal that looks an awful lot like the terminal that you launched JupyterLab from. But now this is running from within JupyterLab. You can see that it puts you in your existing Conda environment, and you can see that it starts you in the directory that you launched JupyterLab from. So we can do things at the terminal here, such as I can create a test directory again, just like I did before. And if I go over to the file browser tab, you should notice that directory was created. If not, hit refresh, and now you'll see it. I can do rmdir test, get rid of that directory, and file browser catches up. If it doesn't, hit refresh. If you go back over to the running terminals and kernels tab, what you should also notice here is that your terminal that is running over here is listed on this, in this page. So if you were to shut down this tab with this X button, pretty common on most tabs, such as tabs on your browser, for example, it would go away, but it would still be running in the background. And so to get it back, all you'd have to do is click on it in the running kernels and terminals tab. And if you don't get your prompt back, just hit enter or return and you get your prompt back. To fully shut this down, you either need to click the X in the running terminals and kernels tab to shut the terminal down entirely, or type exit in the terminal window itself, enter, and that will shut it down. Okay, now we're back to the launcher. And what we're going to look at now is the console. We have one kind of console available in this section because the only thing we've installed so far, the only kernel we've installed, is Python 3. So I'm going to just go ahead and click that console. And what it loads for me is what looks like an IPython console. If you're not familiar with IPython, don't worry about it. Just think of this as a way of executing Python commands in a sort of standalone safe environment. It's good for testing. Down up at the top, you see the output that's produced by launching the console. And down at the bottom, you should see what's called a cell. And this allows you to type text code, Python code, into this cell, such as this, and execute it. And the way that you execute it is you hold Shift and hit return or enter. And what results is the contents of the cell get displayed up above, and you see it gets labeled with this 1. And below it is the standard output that was produced from running the cell. Now, I'm going to do another cell here. I'm going to create a Python string called hello world. I'm going to print an F string here that says S equals S, like so. And then I'm just going to put S as the last line. The last line in an IPython cell becomes, once it's executed, it becomes the return value for that cell. So it's sort of like the output that was produced by that cell. That's the result of the execution of the last line in the cell. So when I say shift enter or shift return now, what I see up above is first the contents of the cell that I wrote. Next, anything that was printed to standard out or possibly standard error from the execution of that cell and then afterwards, the return value from running that cell, which in this case was the value produced from executing the last line in the cell. So I do this just to point out to you that there's a difference between the output to screen, so to speak, that's what you would print, and the output of the cell being the value produced from executing the last line in that cell. Okay, so now we're done with console. That's all I'm going to cover of that. We'll go up here to the X and close it. Notice that the console is still running in the running tabs and kernels, the running terminals and kernels tab. To stop it, hit the X button to shut it down. And we're back to our launcher again. The next thing I want you to do is look down here at the bottom and click on the text file button. This opens and creates a new text file called untitled.txt. Let's go back to the file browser tab. And you'll notice in the directory, in the root directory, I now have this file listed, untitled.txt. I'm going to put some code into this. I'm going to do what I did in the previous cell on the console. Create a string called hello world. I'm going to print the value of that string. And that's it. Now you'll notice up at the top on this tab, there's a little, instead of seeing the X to close it, you'll see there's a little dot, a little dark dot. That indicates that the file hasn't been saved or that there have been modifications to it. So to save it, you can either hit Control S or Command S on a Mac, or you can go up to File, click on the File menu, and say Save Text. And that then saves the file, and so now everything is up to date. Now what I'm going to do is go over to the File Browser tab, and I'm going to right-click on this new file that I created, and I'm going to rename it. Now, I'm not just going to rename the root, I'm going to rename the extension because it's not a text file now. I've actually written this to be a Python file. And I'm going to call this hello.py. When I hit enter, watch what happens. Jupyter immediately recognized that this is now a Python file, and the text editor syntax highlighted it for me. So it changed the highlighting the moment that it recognized that it was a Python file. Now, go over to the file browser and click the plus button to launch a new launcher. Go down to the terminal button and open a new terminal. Now I have two tabs. I have my running text editor and I've got a terminal. To see both of them, I can change how these tabs are laid out. I can actually click and drag the terminal tab over to the right side of the workspace. And now I can see both windows open simultaneously. And I can even resize the window to get a little bit more workspace. I can do ls, see the contents in the terminal, and I can even now run this file that I've created and I have open in this text editor over here by running python hello.py. And I get what I would expect. I get output to the screen, hello world. So you can see from this, if you followed along in the last tutorial series that Julia led, the Your First tutorial series, we could have done everything in Jupyter that we had done before. But since Jupyter is sort of a complication of its own, we didn't want to add to your learning complications by introducing Jupyter to you at the same time. So now let's go ahead and shut down the terminal. We'll say exit in the terminal, close that down. Now we should just have our text editor open. And now we're ready to open our very first notebook. You can do this in two ways. You can either go over to the file browser, click the launcher button and click the Python 3 notebook button, or You can close that and go to File, New, and launch something from there. If you go to File, New, and select Notebook, what it'll do is it'll open a new tab, a new notebook tab in the workspace, and it'll bring up this dialog box asking, what kernel would you like attached to this notebook? And again, remember, the kernel is the thing that's going to run any executable code that we put in our notebook. At the moment, we only have one kernel installed, so that's the one I'm obviously going to select. And now let's take a look at this interface. The first thing you should notice is that there's a toolbar up at the top. There's a save button, which we can save this just like we did the text file. We can save our notebook file and make that black dot go away, like so. There's a create new cells button. There's a cut, paste, cut, copy, paste button up here. There's a run the cell, stop, and restart the kernel. And then you'll also notice there's a drop-down menu that allows you to change what type of cell you have, either a code, markdown, and raw, and we'll talk about what that means in a second. And then on the far right-hand side of the toolbar, you'll see displayed Python 3, which is the name of the kernel attached to this notebook. And if I click on it like it was a button, I can actually bring up the dialog box and select a new kernel if I want. Next to the name, that button where the kernel name is listed, you'll see a little circle. This is the status icon for the kernel. If it's filled in dark, it means the kernel is executing some code. If it's empty, it means the kernel is sitting idle, waiting to run. Okay. Now let's look down here at the actual notebook that we have. This is the space where our notebook is going to get filled in. I've got my text file open, which I'm going to use in just a little bit. So I'm actually going to click on my notebook and I'm going to drag it over here so that I can see my text file while I'm editing my notebook. And I'm going to draw your attention now to the very first cell. This should look a lot like the cells that we saw in the console that we just executed things in. This cell has two different states. There's command mode or edit mode. Currently, the cell is in command mode, which you can tell by this box being grayed out. If I click inside the box, the background turns white and you can see your blinking cursor, and that tells you you're in edit mode. You can also see down here on the info bar at the bottom of your JupyterLab interface that it says mode edit. If I click to the left of the box of the cell, it switches it back to command mode, and you'll see that also down here in the information bar. The blue bar to the left of the cells tells me that this is the cell that is currently selected. If you're not into using the mouse, you can also change back and forth from command mode to edit mode with the keyboard. When you're in command mode, you can change the selected cell to edit mode by hitting enter or return. If you are in edit mode and want to go back to command mode, you need to hit escape. And that's all there is to that. Now, let's start actually putting our first contents in this notebook. So you'll notice this drop-down menu that I showed you all earlier starts out by default, all cells are code cells. I'm going to change from command mode to edit mode by hitting enter. And I'm going to type import hello. That's going to import this Python file that I created just a little bit ago with the text editor. Just like in the console, I hold Shift and hit return or enter to execute this cell. And what you see is it printed out hello because it executed the print s statement. Incidentally, just as an aside, this is bad practice. If you want to create a Python file that you're only going to use to import into other Python code, you shouldn't have any executable code in there, just function definitions, class definitions, and so forth. But anyway, this is just for demonstration purposes. Now, since I've imported this, what I should have available is this string s, and that should be available to me with hello.s. And if I hit shift return now, what you should see is the output of the cell. This is the last line, and it's the only line in the cell. And just like in the console, the value produced from the last line in the cell becomes the cell's output. And you can see that as the red label with the same label as the input cell. That's the output of the cell. Whereas up on in cell 1, this was just what was printed to standard out. If that's confusing, please ask questions in the chat, but I'm going to go ahead and continue. I'm going to do something a little bit more sophisticated now, and I'm going to say import time. Time is a built-in module that comes with Python. And I'm going to call a function from time called sleep. Sleep is a function that tells the Python kernel to wait, and in this case, 10 seconds. When I execute this with shift return, notice what happens. First, you should notice that next to the cell, there's an asterisk in it, which tells you that the cell is being executed. And up here at the top, you should have noticed the top right, you should have noticed the status icon filled, became dark. If you didn't see it, I'll execute this cell again. And you can see the status icon is filled in while the kernel is in operation. And once it's done, the status icon goes back to blank and the label on that cell is updated. Those are code blocks. In code blocks, you can put any code in there that corresponds to the kernel attached to the notebook. And as I mentioned at the beginning, you can have kernels for Julia or R or any of those. Now I'm going to go ahead and move on to the next type of cell type. I'm going to select my last empty cell, and I'm going to select Markdown. I'm going to go into edit mode by clicking in the box. Markdown, if you're not familiar with it, is a way of taking raw text with some markup symbols in it and re-rendering it making it possible to re-render it in a way that is very pretty and easy to read. So for example, you can do things in Markdown like have a heading followed by some text, have a subheading, and there are 6 levels of headings, and follow that with some text. And Markdown even gives you the ability to do very easy bulleted lists like this, or even numbered lists like this, like that. When you execute a Markdown cell, it will re-render it so that it is pretty in some sense. So if we hit shift return or shift enter, you see the result. This is a way of creating really nice narrative text inside your notebook alongside your code. It's a lot better and easier to read than just code comments. But Jupyter's version of Markdown is special. If I take my next cell now, and I'm going to make it into a Markdown cell, go into edit mode, Jupyter's version of Markdown also has the ability to have equations using LaTeX. So I can write something like this. And if you're not familiar with LaTeX, don't get scared. You don't have to know it. But this is basically saying e to the x is equal to the sum from 0 to infinity of x to the I over I factorial. And when I execute this, shift return, it should display this nicely so that it's easy to read. You can also do inline equations. So I'll change this next cell to markdown as well. And I can do inline equations by saying something like this is an equation with just single dollar signs, I to the 4th power dot. And then when I do shift return here or shift enter, it renders it inline. So this gives you the ability to really create very readable narrative alongside your code. Okay, the last type of cell type is a raw cell. So I'm going to change the next cell to raw and go into edit mode, and I'm going to type some Python code in it, for example, like this. When you execute a raw cell, nothing happens. It doesn't get executed in the kernel. It doesn't get rendered like Markdown. It just gets left as is, and that's it. And that's all we'll say about raw. So now that we've got a few cells created, it's worthwhile to start talking about command mode. You've seen what edit mode gives you. Edit mode gives you the ability to actually write content into the cells. Command mode gives you some nice little shortcuts in here. So for example, one of the things you can do is you can see here I have this big selected markdown cell, and I can use the up and down arrows to move up and down through the cells. I can also use the A button, the A key, to create a new cell above the currently selected cell, like so. And I can use the B key to create a new cell below the currently selected cell, like so. There's also cut, copy, and paste. So I can hit X in command mode. I can hit X to cut a cell. And if I hit V to paste it, it'll paste it below the currently selected cell, so forth. If I hit C on a selected cell and hit V, it pastes a copy of that cell. So there are some nice, convenient things you can do in command mode that are a little harder to do. You can also use the mouse, by the way, to actually take a cell and move it around, move its position in the document. This should immediately point out to you that you can execute cells in any order you want, which can be really dangerous, because if you look up at the top of our notebook here, you'll notice if I decided to execute cell 2 before I executed cell 1, I'd get an error because it hadn't been imported yet. So in general, be careful about the order of execution for the cells. Okay, now Jupyter also has some special variables that it creates, even if you don't create them for you, even if you don't create them yourself. So for example, the underscore, it's a perfectly valid Python variable. It's a shortcut for the last output produced by a cell. So if I scroll up here, you'll notice, so I got a bunch of markdown cells. They don't have output. The only cell that actually has an output is cell 2. So this should correspond to the output of cell 2. And in fact, it is. But I can also directly reference it by saying underscore 2. And that gives me now the output of cell 2 directly. That's a little obscure though, and maybe you want to use underscore for other things in your notebook. Fortunately, Jupyter also gives you the variable out, which is actually a dictionary, and you can give it the label for the cell, and it will also give you the same thing. And if you're thinking out is a variable that I can reference, maybe in is a variable as well, and you're right. This gives you the input to cell 2, which was hello.s. But you'll notice it gives it to you as a string. Okay, other things you can do in Jupyter Notebooks. You can run shell commands from within cells. So for example, there's a shell command, a bash shell command called pwd, and I can execute it in a shell by preceding it by this exclamation point. If I then execute this, I see that's the current working directory, the present working directory that I'm sitting in. But instead of just doing the cell only executing that one shell command, you can actually, Jupyter will give you the ability of linking the output of shell commands into Python code. So I could actually write something like files equals exclamation point ls print files. And sure enough, when I execute this, it works. It actually calls the shell command ls, pipes that result into the Python variable files, and then I just printed that Python variable. Other things that you might need to worry about when running Jupyter Notebooks are dealing with the actual kernel. So as I mentioned before, you can run these cells in any order you want. And sometimes you can run into two different problems. One problem is you may run a cell, and for any number of reasons, it just takes forever. Maybe you just had a bit of a spasm and put too many zeros after the 1. And when you execute it, it's just going to keep running, for 10,000 seconds. And that's a long time. So as long as it's running and as long as the kernel is still in operation, is still busy, you can't do anything else in your notebook. At least you can't run any code cells. So what you may need to do in that case is go up to the toolbar and hit the stop button to interrupt the kernel. And you see it gives it essentially the equivalent of hitting Control-C. It gives you a keyboard interrupt. And as I mentioned, you can run these cells in any order, and that can actually put you in a very weird state. So you may actually need to restart the kernel. And that's what this circle error next to the stop button does. If you click that, it'll ask you, do you want to restart the kernel? You say restart. And now, even though the output is still in your notebook, the kernel has been completely restarted and it has forgotten everything you've run. So now you've got to go back up to the top and execute everything in sequence to get back to where you were. Okay, I can continue executing these, so forth. And then I can go back now and fix this and make this just sleep 1, for example. The last thing I'm going to talk about in regards to notebooks are things called magics. Magics are commands that you can put in your cell, in your code cells, that start with an exclamation point. Sorry, not an exclamation point, a % sign. There are a lot of magics out there that you can use, but I'm just going to demonstrate magics through the use of the time it magic. This magic will time a line in your cell. So for example, if I ran the function sleep1 and executed this, it should give me how long it took to run sleep1. But you'll notice it takes a lot longer than 1 second. And that's because it's actually running the cell, that line, multiple times and giving you statistics on it. So you can see it actually ran it 7 times, and I got 1 second plus or minus 1.55 milliseconds. There's also such a thing as a cell magic, which is a command preceded by 2% symbols. And for example, the time it cell magic will allow you to time not just a single line in the cell, but an entire cell's execution. And this is handy for doing any type of performance optimization or trying to figure out why something takes a long time. Okay, that's everything that I wanted to cover regarding Jupyter Notebooks. So what I'm going to teach you now is how to shut this all down. So I'm going to hit save, good thing to do before shutting anything down. Hit the X button to shut that down, hit the X button to shut that, and you'll see it brings me back to my kernel. If I go back to my running terminals and kernels tab on the far left, you'll see I have the kernel for the notebook I had open still running. I can shut that down. And then to actually shut Jupyter down, I need to go to File, Shut Down. I'm going to go ahead and do that. It'll ask for confirmation, and it'll tell me the server has stopped. Now I'm going to go back to my terminal that I had open before, where I launched Jupyter to begin with. And what you should see is that all of the output from the running JupyterLab has stopped, and I've got my prompt back. Now, the one last thing that I'm going to cover in this tutorial, just about JupyterLab, is that you can create your own kernels for custom Conda environments. And so at the moment, when we've installed a fresh install of JupyterLab, we only had one kernel available to us, and that was the Python 3 kernel. What I'm going to show you now is how to turn any of your Python installed Conda environments that are on your system into a kernel that you can use in Jupyter. So first, you'll notice I'm in the Jupyter tutorial Conda environment. So I'm going to do a Conda deactivate to get out of that. Then I'm going to Conda activate any other Python environment that I happen to have. If you followed along in the last tutorials, you'll know we had a Python virtual environment called Python tutorial, and I can activate that. And I can use Conda to install in this environment a package called IPy kernel. When you install this package in a environment with Python in it, it will convert that environment, or it'll make that environment usable as a kernel from within JupyterLab. Now, I think I've already installed this, so it's going to tell me there's nothing new to install, I think. Yeah, but you may have to go through the process of actually installing it in whatever environment you want. Then in order to see that environment as a kernel in Jupyter, I need to go back to where I have JupyterLab installed. So I'm going to do a Conda deactivate. Then I'm going to do a Conda activate Jupyter tutorial. And then I'm going to do Conda install nb underscore Conda kernels. If you install this package with Conda in the same environment where you have JupyterLab installed, it will make JupyterLab capable of seeing all of your other Conda environments that have IPy kernel as kernels. It can take a little bit to install. It's a pretty small package, so it doesn't do a whole lot. I'm going to say proceed. And now it should be available. And so now, if I were to start JupyterLab again, just as I had done before. It should take me back to my browser. And I'll share with you what I see. And you should see not just the Python 3 kernel that was installed with Jupyter, but every other Conda environment that had Python and the IPy kernel package installed. And I have a lot of them on my system. You may only have the one that you tested things out with. But now, going into the future, all you have to do is just install IPy kernel in any Python virtual environment you happen to have, and it will be accessible from within JupyterLab. Thank you. That's all I have to cover today, and I'm happy. I realize we don't have a lot of time left, but I'm happy to answer any particular questions.
I've got a question.
Yes.
I came in late and I've just got mini Conda installed, but I don't know where I can get the Jupyter tutorial. Is there some place where I can get instructions for getting this all installed?
So as I mentioned in the tutorial, all you need to do if you've got mini Conda installed is execute conda create -- name Jupyter tutorial and then space JupyterLab. And if you execute that, it should create a new Conda environment and install JupyterLab into that environment.
Okay. Conda create -- name.
Space, you give it any name you want, frankly. It could be just called JLab, and then space JupyterLab, one word.
Well, it's doing something. Oh, it wants to install all sorts of things. Okay, great. Well, that's
Yes.
getting me one step further. Thank you.
Okay, good. Yeah. Yes, JupyterLab comes with a lot of dependencies, which is another reason why it's nice to install things in virtual environments, especially in the Python space, because many packages have dozens of dependencies. And so just to make sure that you don't get conflicts with what's installed in your system, it can be really nice to install all of those things in virtual environments and not create those conflicts.
Okay. Well, thank
Okay.
you.
I have a brief question about resource usage with virtual environments.
Yeah.
Some of our system people, complain if we have way too many virtual environments, and I'm not sure what resources they're hogging, but they seem to be saying that that's annoying them.
So
how do we manage that?
As long as code, as long as any executables or something that are in your virtual environments are not running, it shouldn't be using any resources except disk space. Unless you happen to have, this is the one example where I can think that that statement makes sense. If you have a system-wide install of Anaconda or Conda, so in other words, everybody's using the same Conda and installing their own environments in their own user spaces, that could create some resource conflict, but I'm not sure why you should be having any resource hogging or excessive resource use just because you've installed a lot of different virtual environments.
Because assumably it downloads these packages and puts them there, and if you have 100 people with 100 packages each, that gets pretty bad, I guess is what I mean.
Yeah, right.
I just didn't want to overload my own laptop by doing something stupid is really what I'm asking when I'm asking this.
No, that's entirely true. So I hope actually later through this series, we're going to have an advanced Conda tutorial, and we'll talk about things like managing your Conda space. Because the one thing that Conda gives you is the ability to install software in your own user space. But the inherent problem that creates is that you can get a ton of duplication. If there are 200 users on your system and they all install Conda and they all use Conda to install NumPy, every single one of those users has a duplicated install of NumPy. So it can be sort of a waste of disk resources, but it also gives you a lot of power in that it gives you the ability to manage your own software stack instead of depending upon sysadmins to manage it for you. And potentially needing to update, and then someone updates the software and it breaks other people's software, so on and so forth.
I will also add that for NCAR users specifically, you don't want to install Conda in your home directory on Glade, because it'll use up all the space as you make environments, and it caches packages for you.
Yeah, that's a very good point too. It can definitely use up space. I recommend using your workspace on Cheyenne if that's where you want to install it, and use everything out of your workspace. And then pruning things periodically is a good idea too. There are some commands that you can use to clean up all of the downloaded packages, like the cached packages, for example. You can prune unused virtual environments. How do you prune? Okay, I just saw that come up. So there's a command that you can type. I'll type it into the chat here to delete virtual environments that looks like this. env, it's going to capitalize it. You don't need to capitalize it. Remove name env, something like that. That command will actually, oops, sorry, I sent that to one person and one person only. Okay, the command looks like that. That's a way of removing an environment. We don't usually present it at the beginning because you have to be using Conda for a while to run into these problems. It's a little bit strange that you have to. Oh, there's also there. Thank you, Brian. There's Conda clean. That one I think cleans up the cached packages that you've downloaded. And there are probably others out there. I'd have to familiarize myself with them.
I can say I look forward to your advanced Conda management after a few months of doing this.
Yeah, exactly. So we may not do it, in a month. We may do it in a little while. I'll give people some time to see these things. Someone asked the question, where are the packages physically installed in a virtual environment? Well, if you have Mini Conda installed, and presumably you know where it was installed. If you went into the directory where Mini Conda was installed, you should see a directory called, let's see here, I'll also type this into the chat, to Mini Conda 3, for example. There will be a directory called ENVS, and every single named environment will get put into that directory, and they're all clearly separated from each other. So you can even just delete a directory from that ENVS in there, but it's really better to go through the Conda command so that it cleans up anything after deletion for you. That also tells you can look in ENVS and you'll notice if you've got, for example, an environment called myenv, you'll see that there's a directory called bin, like that. And that will contain your Python executable that was installed for that environment, or any other executables that were installed in that environment. And so you can actually run that executable with the full path without activating your environment. It's just handier to activate your environment and make sure everything is set up properly. Good point, Mike. So Mike Levy pointed out there's an environment variable, at least on Macs, that is called Conda _ prefix that will actually tell you where your mini Conda is installed. Someone asked, why use mini Conda as opposed to Anaconda? Mini Conda is much more lightweight. Anaconda is mini Conda plus a whole bunch of default packages. And maybe you want those packages, maybe you don't. I personally always find it's nicer to start out small and build up only what I need or only what I want to use. But if you want to go the whole, get me the entire Anaconda package distribution and download it all to my computer, sure, you can do that. And you can install Anaconda. Otherwise, both of them come with Conda, and everything else from there works the same. Have I missed any questions that either weren't asked in the chat or any new questions? Okay. Well, if there are no more questions, I want to thank everybody for sticking around. I hope that was helpful. If you have any feedback, you can send it to xdev@ucar.edu, and we're happy to help you out.